Okay, dear students, the last two operations on rational expressions are adding and subtracting the rational expressions. Okay. The sum or difference of two rational expressions, p of x over q of x and r of x over t of x, is defined as. Okay, first let me say that both addition and subtraction of rational expressions solutions are the same. Okay, it means you're going through to solve the questions the same as addition and subtraction. Okay, so at the end it's a little bit different. You're going to add or subtract, that's it. Okay, p of x over q of x plus or minus r of x over t of x. This is the first solution, that you're going to multiply the numerator and denominator of first fraction by the denominator of the second fraction. Okay, p of x or over q of x times t of x. Okay, both numerator and denominator of the first fraction with the what? Denominator of the second fraction, plus or minus the second fraction r of x over t of x. You are going to multiply them with the denominator of the first fraction. Okay, why? Because we are going to assimilate the denominators. Okay, look, q of x, t of x, t of x, q of x. Okay, then if the denominators are the same, we are just what? Add or subtract the numerators. Okay, this solution is why, because we have to assimilate the denominators. So q of x, t of x, t of x, q of x, then denominator are the same. We are going to take just one denominator and add or subtract the numerators, p of x, t of x, plus or minus r of x and q of x. Okay, let me show an example. We have 2x over x minus 3 plus minus x minus 2 over x plus 4. Okay, in order to solve it, we are going to multiply the first fraction with the denominator of the second fraction, x plus 4, x plus 4, plus or minus the second fraction, x plus 4, with the what? Denominator of the first fraction, x minus 3, x minus 3. Then, as you see, the denominators are the same. We are going to just take one denominator, x minus 3 times x plus 4, and we are going to add the what? The numerators, 2x times x plus 4 plus and minus x minus 2 times x minus 3. Okay, and also we have another solution. When we add or subtract two rational expressions, we use the following procedure. First, find least common multiple of the denominators and change each fraction to an equivalent fraction with the denominator. It means first you have to find the denominator of the LCM of the denominators. And why we are doing this procedure to equivalent fractions with the denominator? It means we have to what? We have to equal the fraction, the denominator of the fractions. At second procedure, combine the fractions and simplify if necessary. If needed, if it's simplifiable or if it's cancelable, you can what? Combine them, combine the fractions. Okay, first of all, finding the LCM. LCM of what? X and x squared. Okay, how can we find the LCM of x and x squared? We have said at the previous lesson that in order to find the LCM of two numbers or two polynomials expression, doesn't matter, we have to take the non-common and the common multiple what? With the highest power. Okay, in here we don't have any non-common to take it out. Okay, we have just common x. In here we have x, and here we have x squared. So LCM of these two numbers is x squared. So we have x squared here. We are going to what? divide x squared by x, and after that multiply with denominators, each one by one, okay? X squared divided by x is equal to what? X. X times 3, 3x, plus x squared divided by x squared is equal to 1. 1 times 4 is 4. So this is the final answer, okay? First of all, you have to take the LCM. After that, like simple fractions, addition of simple fractions, if denominators are different, you have to find the LCM, and after that, LCM divided by denominator of each fraction times what? The result times the numerator of each fraction. Okay, second example. 4 over 8 cubed minus 2 over a squared plus 1 over a. Okay, first of all, we have to find the LCM of what? A cubed, a squared, and a. Okay, as you see, we have a times a, and a times a times a. Okay, so we have common multiple. What's the common multiple? A. So which one has the highest power? A cubed. So LCM is equal to a cubed. A cubed times a cubed, 1. 1 times 4, 4. A cubed times a squared, what? A. And here we have minus. So minus a. Am I right? A cubed times divided by a is equal to a squared, plus a squared times 1 is equal to a squared. Did you get it? Okay, boys. The third questions. Also, we have 3 fractions with different denominators. First of all, we have to find the LCM of x minus 2, x plus 2, and x squared minus 4. Okay, x minus 2, x plus 2, and x squared minus 4. As we studied at the previous lessons, identity a to the power of 2 minus b to the power of 2 was equal to a minus b, a plus b. Am I right? So in here, x squared minus 4 is equal to x squared minus 2 squared. Then it equals to x minus 2, x plus 2. So the LCM is x minus 2 times x plus 2. It means x squared minus 4. Okay, when we divide x squared minus 4 by x plus 2, so we get what? X minus 2. X minus 2 times 2. Plus, okay, x squared minus 4 divided by x minus 2 will be equal to x plus 2. X plus 2 times 3. Okay, so x squared minus 4 divided by x squared minus 4 is equal to 1. 1 times 4x minus, because we have subtraction, minus 4x. Okay, then we have to what? Combine it. It means multiply each common factor with the each term of the parentheses. 2 times x, 2x. 2 times 2, minus 4, plus 3x plus 6 minus 4x over x squared minus 4. So it equals to, we have 2x plus 3x, 5x. 5x minus 4x is equal to 1x. Minus 4 plus 6 is equal to plus 2. Am I right? At the denominator, we have said that x squared minus 4 is equal to x squared minus 2 squared is equal to x minus 2 times x plus 2. We can write x minus 2 times x plus 2. So we have x plus 2 at the numerator. Then we can cancel them, okay? So the answer will be 1 over x minus 2. Okay, thanks dear students. This was the operation on rational expressions. If you have any suggestion or comment, just write it below. Thanks for watching.